Now we've seen examples where our lines cross at just one point, and we've seen an example where the lines never cross. Let's see what happens when we try to solve the system. 4x plus 3y equals 12, and 8x plus 6y equals 24. Again, I'm going to call these equations A and B, and I'm going to find their intercepts. For A, first I'm going to let x be 0. 4 times 0, that's just 0. 3y equals 12. Divide both sides by 3 and we get y equals 4. So this will be the point 0, comma 4. For the other intercept, I will let y be 0. 4x plus 3 times 0 equals 12. 3 times 0, that's just 0. Divide both sides by 4, and we get x equals 3. So this gives us the point 3, comma 0. So we graph 0, 4, and 3, 0, and draw in the line. B, we're going to play the same game. Why don't you pause the video and try finding the intercepts for B? Pause the video, give that a try now. Okay, let's see what happens. First we'll let x equal 0. 8 times 0 plus 6y equals 24. So this is just 6y equals 24. Divide both sides by 6 and we get y equals 4. 0, comma 4. Hey, I think I know where these guys are going to cross. But let's keep going. Let y be 0. 8x plus 6 times 0 equals 24. This is just 8x equals 24. Divide both sides by 8. What do we get? X equals 3 again. 3, comma 0. Oh, what just happened? We graph 0, 4, and 3, 0. What just happened? These are the same line. Maybe you were already onto that, right? Maybe you saw that we could go from this equation to this one by multiplying both sides by 2. So because these two equations describe the same line, there isn't just one solution. Every point on this line is a solution to the system. Now, be really, really careful. Right? It's not that every point is a solution to the system. For example, this point, -3, -3, which is not on the line, that's not a solution to this system. So we can't say, for example, all real numbers are a solution. What we do say is there are infinitely many solutions to this system. So we have one more term for this kind of system. Remember when we said when the lines cross at one point, it's consistent independent? When we have a system like this, where they're the same line, we call this system consistent. That is, they can be true at the same time, dependent. Not only can they be true at the same time, they're always and only true at the same time. If we know whether one is true, we know all about the other one. So they are consistent, but they're dependent on one another. A system like this is consistent dependent.